Hi, in our previous sessions, we learned about the standard VHDL data types, custom data types, and array-based data types, etc. And we learned that what are the good practices and how to use those data types and their concepts effectively in our VHDL designs. However, those concepts was great for grouping the same data types, but they do not allow you to work when your project needs group of different data types. For example, some data can be integer, some can be std logic vector, some can be boolean, like that. So in VHDL, you will have record feature to work on such a specific requirement. Records in VHDL allows you to group different data types into the one single record. Let's understand this with some examples. So suppose we are designing a RAM module which is acting as a memory element in some high level system. So first let's figure out that what we are actually needing to design a simple RAM element which has 8-bit data lines for reading or writing of data. It has address line and one read-write select pin. So this RAM module has 8-bit data lines. This means that we have two signals of std logic vector 7 down to 0, one for reading the data from the memory and another is writing the data into the memory. So it can read 8-bit data from the RAM or can write 8-bit data into the RAM, and this will be controlled by the select pin. So we have another std underscore logic signal which is rw underscore select. Suppose 0 is for reading the data and 1 is for writing the data. There is one more important thing in RAM which is address. So you need to specify from which location RAM should read or write the data. So I am needing address signal as well. I defined it as an integer which is having the range of 0 to 255. Simple. Okay, so once we are done with this requirements, it's time to create the VHDL record. So for this requirement, I will write type RAM type is record signal data underscore write colon std underscore logic underscore vector 7 down to 0 semicolon. Next, signal data read colon std underscore logic underscore vector 7 down to 0 semicolon. Next, signal address colon integer range 0 to 255 semicolon. Signal rw underscore select colon std underscore logic semicolon and record semicolon. Let's quickly understand this. So first signal is for writing the 8-bit data into the memory. So this is std underscore logic underscore vector 7 down to 0. Same, the second signal is for reading the 8-bit data. So this is again std underscore logic underscore vector 7 down to 0. Address is integer type and having the range from 0 to 255. RW select signal is for selection. Either memory is being used for reading the data or it is being used for writing the data. Okay, so first of all, this is just a sample. Actual RAM would also require more pins like chip select, clock signals, etc. So you can configure whatever it is needed for your project. Okay, so we have created a record, but now the question is that how I will use it in our project, because just creating a record will not do anything in your design until you are defining a signal and use that into your project. So after defining the VHDL record, second step is to declare a signal for your record data type. So syntax is exactly same like we did many times in the previous sessions, which is signal, signal name, colon, data type, semicolon. For example, signal RAM colon RAM underscore type semicolon. Now look at the bottom section of the slide. Here you will see that how you can use the signal for assignments. It's not that straightforward like the set of single data types which we have used in the previous sessions. Because this record data type holds 4 different type of signals inside it. So you need to specify that what signals you are currently using for assignment. Well, this is very easy to read. To access any element of your record, you need to use a dot symbol next to the signal name. For example, first is ram.data_write gets the value of x80 semicolon. Now this statement will assign hex 80 value to the data write pin of the RAM signal. Same, to access the RAM address, simply write ram.address gets the value of 14 semicolon. So the address point 14 will be selected for action. Next example is rw select. So write ram.rw select gets a value of 1 semicolon. So this signal will tell that I am going to write on the RAM. Simple, right? Now to conclude here that you must notice that there are 4 elements in this RAM type record, like read pins, write pins, address line and the RW selection pin. However, this is not mandated to use the records for all such type of requirements. As an alternate option, you can also declare those 4 elements individually by creating 4 individual signals, right? So the question is that why you should use record, or even should you prefer records feature in the VHDL? Well, it's completely based on the preferences. However, if you are reusing this structure in your VHDL designs very frequently, then it is better choice to use the VHDL records because you declared everything which is needed in one single place. So you do not need to declare all signals every time. But if you have the requirement where you need this only once, then you can also declare individual signals inside your designs. Okay, so now it's time for a quick summary, whatever we have learned in the data types yet. So we learned standard VHDL data types like std logic vector, integer, boolean, string, and custom data types as well. We learned how to create custom data types. We learned that how to declare any type of signals. We learned that how the assignments works in VHDL. We learned about the array-based data types for grouping same set of data types. We talked about unconstrained array. We learned about the records in VHDL for grouping set of different data types. So I hope that now you have the good foundation on VHDL data types and their use cases. And in the next session, we will be talking about constant. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for the regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.